Hello and welcome back. Now this is the time when we create our Java program in our Raspberry Pi. Now the steps are very simple, and you can also find the steps in our blog. In UI5CN, this is the fourth part of SAP HANA IoT with Arduino and Raspberry Pi. So we are going to cover these steps one by one. So the first step is to create a directory where you want to save your Java file. Now let me make a directory with the command mkdir, and I will name it demo HANA IoT. Now I will go inside this directory by the command cd, which is change directory. If I press tab here, then it will show me all the options available, and I will hit enter. Now I can do a dir to list all the content inside the directory. Now this information are very generic, because if you are used to command line interface, then these are something very common. But this is a refresher for those who are seeing command line after a long time. So there is nothing inside my current directory, so I have to create a new file. Now we can create a new file in many ways. Let me show you some of the ways which you can do this. The most simplest way is to use touch. Touch is a command in which you can create the file very quickly. Let me create a test.java, and if I do a dir again, you can find test.java here. Now we are going to create our file using Nano, because Nano and VI are one of the most popular editor in Linux, and many of you who are using Linux for day-to-day activity will be very familiar with that as well. So what I'm going to do, I'm going to type the name of the program. The name of the program will be the name of the public class of our Java program. Now let me copy here. Now the name of the program will be cdl test get.java. Now remember that Linux is case sensitive, and if I do a typing mistake in my cases, then there would be a problem. So just keep that in mind. Now I am inside my file, and I have to save this file. Now to save this file, I have to press Ctrl O and press enter, and I will do exit by pressing Ctrl X. If I do a dir now, you can see I have two files. Now the first one we created to see touch, and the second one from Nano. Now I'm not going to use Nano or VI editor to do copy paste, because we have a option of graphical user interface with our Raspberry Pi as well. So let me open one more session of my putty, and then we will use gedit. So if I open one more session, I have to enter IP here and also enable X11. The credentials are same, Pi and Raspberry, which are default. Now I will be opening a new GUI session with ls session command. Now in the other window, I will be opening Here I will be installing gedit. So for that I will be writing sudo apt get install gedit. I already have gedit in my machine, but if you don't have, then this is the command to install gedit. Now I will go to my directory where I have created my program. So let's check where's the directory. This is demo henna IoT. So if I go here, open, and then I go to desktop. So you can see inside my home folder, you have demo henna IoT folder. You have to go inside this and you have to right click in our newly created program and open with gedit. Now gedit is very fast editor, and even if you are running in Raspberry Pi, it will be very quick. Now what I'm going to do, I'm going to copy my Java program in my gedit editor. So let me copy it. Simple, doing a copy paste. Now the libraries specifically important in our program are gnu.io.star, because these 4 libraries will be responsible for handling our port which is connected to Raspberry Pi and Arduino. So if I walk through the code, let me open my blog here because the indentation is very nice here, so it will be easier to understand. So you can see I'm passing the parameter of the port name. This is the port which will be used by our Raspbian operating system of Raspberry Pi. If you are using the same Java program in Windows, then you will be using COM3 port. Previously we saw that we are using COM18 port. You have to hardcode the COM18 port here and replace it. Now the same program will also work with Mac and other Linux operating system. Now the important part in our program, if we see here that we have this property which we set of our COM port. Now this part is written inside our initialization. Now what will actually happen, we are actually having an event, and that event will be actually responsible for reading data from our serial port. Whenever there is a serial data available in our Raspberry Pi serial port, the data can be from Arduino or any other devices which are connected in the serial port, then this function will be executed and we will be passed a serial port event object. Now we are just first checking if the data available is of the right type, and once we do that confirmation, then we read the buffer reader. So here if you see input is actually the buffer reader. If I go to top, then you can see here this is buffer reader. Now what I'm going to do is I'm going to read this buffer reader and invoke a custom function called sendGet. Now sendGet is actually where all the activities related to our use case is happening. Now here what I'm doing, I'm actually getting the input in a string format. So first I am converting the string into an integer by using %. Now there is a very unique thing I am doing here which is essential, because I don't want to have so much number of data points which are redundant. So I am only considering those data points which are more than 3 of the previous one or less than 3 of the previous one. That is, if my current reading is 12 and if I get a 16, then I will be considering it as a new data point, or if it's a 9, because I don't want to store another data point which is 12 or 13, because that are relatively same, and this will reduce the data set of my HANA database. But in a real project you should not be doing this, because all the data points are essential in a real life world. Now if you see here, this is my URL of my SAP HANA Access who will be storing the data points. Now I have hard-coded my sensor ID here, but you can actually pass it as a parameter to your function. Now what I'm doing here, I'm appending my value which I got from my serial reader into this URL, and I'm calling this URL. Now as you can see here, my HANA system IP seems to be a bit different because there is no IP. That's actually done for security purposes, but this will be actually in real life your complete URL for accessing your HANA Access.js services. Now this is actually the basic working of your Java program which will be running in your Raspberry Pi. You can go ahead and see other parts of the Java program. This is actually a sample program which you can also download in Arduino's official website. But there are some modifications which is related to our own specific use case I have done here. So it would be better if you copy this program and do the changes in the URL, and you are good to go. Now what we are going to do, we are going to compile this Java program. So we go inside our command line interface, but we need to also save our Java program in gedit. So I will press Ctrl S for this, and it is saved. So let me verify it using nano. If I press nano and I press serial test get.java, you can see our Java program is already saved. Now to compile this program, you can also refer to my blog for the compilation statement, because you have to compile the Java program with your source and target with 1.6 version compatibility, and it compiled with one warning that was related to bootstrap class path, but our Java program will work. So if you see the compilation statement again, then I am giving a class path for my rxtx.com.jar file. Now this file is actually required in your Java program because it is responsible for your libraries files which we mentioned. Let me come back to a top. Now here you can see you have some gnu.io library files. There are actually 4 of them. So these 4 files is actually provided by your rxtx.com jar file, and they would be required in your compilation phase. Now what we are going to do, we are going to run the class file which is generated from the compilation. Let me see if we got the class file. You can see here we got serial test get. Now finally we are going to run our compile program. Let us compile that. The name of the file is serial test get, and now you can see here the results are shown. Now my Raspberry Pi is reading the serial port from Arduino and it's printing all in the console for now. Once we do the final integration with SAP HANA, we will replace the URL with the actual URL of our Access.js script. Now in the next section we will be talking about configuration of SAP, and we will start with SAP HANA. To summarize this section, we saw how to connect Raspberry Pi and Arduino. Then we wrote a Java program which is able to read Arduino serial data. The next section, we are going to transform from a hardware hacker to a SAP consultant. Now what we are going to do is we are going to first set up our SAP HANA system, and then we are going to set up SAP UI5 application on top of it, which is able to read the information. Thank you for watching this video.